So that's kind of my take on the Uni Wheel. Tell me what you guys think in the comments below. Thanks for watching, guys. Hello, everyone. It's Steve with Aptera Owners Club. Several weeks ago, Hyundai Motor Group announced that they had developed something they called the Uni Wheel, which they believe solves some of the problems with space management in electric vehicles. It's an interesting concept. I thought it was, in many ways, very ingenious, but then in many ways, far inferior to the hub motor design that Aptera is using. So I wanted to talk about it. I'm not an automotive engineer. I'm a little bit of a backyard mechanic. I've done some minor mechanic work. I've replaced a few CV joints in my time. But this is how I understand it, so I thought we'd talk about it together.
Changing drivetrain. Let's take an electric car, for example. The motor spins at a high speed to generate power. The reducer reduces the motor rotation speed and increases torque output. And the drive shaft sends power to each wheel. In between the power source and the wheel, on either side of the drive shaft, is the CV joint. It's a special component that transfers power from the motor to the wheels at a constant speed, even when the wheels are moving in all directions on uneven roads. Until now, this structure was the natural choice. Even when transitioning from internal combustion engines to electric vehicles, the drivetrain didn't change much. But as mobility transitioned to make versatile use of interior space, this became an issue. The parts take up so much space. If you reduce the amount of space the parts take up, won't there be more space inside? Maybe. But in order to move the motor and make space between the wheels, the length of the drive shaft must be short.
Okay, so the problem here is as the suspension moves up and down, if you shorten it, then the angles become more. And another thing that this video doesn't talk about is as this angulates, if you keep this distance the same, this at a steeper angle, it has to get longer and then shorter, because this distance will change as the angle gets steeper like this. So this, if you want to keep it at the same distance between here and here, if you go like this, from here to here is going to be longer than from here to here. So this thing has to be able to translate laterally to account for that. And I don't see anything in this presentation that accounts for that.
Important. This would increase the angle of the CV joint and reduce efficiency.
Right. So when the CV joint, which stands for constant velocity joint, if it's angulated a lot, it loses a lot of energy to friction. So the straighter it is, the better it is.
Durability and ride quality. Oh, wait a second. What if we take the CV joint, drive shaft, and reducer and move them all into the wheel? Then split the motor into smaller components and move them into each wheel. That right there is the Uni Wheel. Introducing the Universal Wheel Drive System. It's a functionally integrated wheel that completely changes the drivetrain paradigm. The Uni Wheel is comprised of 4 pinion gears placed on either side of the sun gear. These all mesh together to rotate the ring gear. How does it work? First, the motor generates power and transmits it to the sun gear, turning the pinion gears on either side, which in turn spin the ring gear. This ring gear is connected to the wheel and provides the power to turn the wheel. From there, the linkage assembly, which is composed of the pinion gears, moves, completing the motion of...
Okay, so in this, what they don't see is you don't see the control arms. The control arms, the upper and lower control arm, are going to have to angulate. And so as they angulate, the distance between here and here will change. And this thing needs to have some kind of translational motion laterally to account for that.
of the wheel. The coolest part of Uni Wheel is its ability to move freely even when transmitting power. Torque can be controlled regardless of the wheel's movement, which allows for the wheel's torque output to be
Now this part is really cool, how they have it so that it can move in all these directions,
continuous and smooth.
It still maintains, you can maintain a straight orientation between the wheel and the motor.
The result is an entirely new type of wheel that is constantly transmitting power, yet has freedom in its movement. What's more, you don't need a separate reducer to achieve the necessary reduction rate, just the gear ratio between the ring gear and the sun gear. It was a bumpy ride to find the optimal structure. We tested countless structures and possibilities. Now, what happens when you install the Uni Wheel to a vehicle? Voila! This space can now be utilized in the...
And so let's compare this to the hub motor. In the hub motor, this is completely gone. Like there's none of this. It's just the wires and the coolant go straight to here. Let's take a look. Okay, so here we go. This is showing the Lightyear and the Aptera. This is from Alafe's website. And you can see here that it's moved all the components out to the hub right here. So the controllers are in here. So you're going to have these in the Uni Wheel as well. And all that's going out are the high voltage wires and the coolant wires. And everything is enclosed in here. So that moves all the components. It moves everything out here. And this is a much simpler system. It's far less gears. There's only like one wheel bearing that has a 1,000,000-mile maintenance schedule that you have to worry about. There's no system of like planetary gears and pinion gears and sun gears and ring gears to worry about. And I don't know, let's take a look back at it.
Interior. But how well does the Uni Wheel function? In existing systems, the efficiency of the power transferred from the motor can vary depending on the movement of the wheel. With traditional CV-jointed drive shafts, the efficiency of the power transfer decreases when the angle of the wheel changes.
Right, so their system negates some of that power loss as the CV joint is angulated, but so does the hub motor. And this one, look at how many gears there are. There's so many points of failure on this thing. And I don't know how heavy this would be. The one advantage of this over the hub motor is I think this is going to be lighter. So it's heavier than the previous system with a CV joint going into it, but it is lighter than a hub motor because the motor is off, the weight of the motor is offloaded onto the car. So that is not unsprung weight. So the unsprung weight of this is going to be less than the unsprung weight of a hub motor.
However, Uni Wheel is...
But this looks way more complicated.
Different. In a test of the Uni Wheel with a 150mm stroke, it was found that the transmission efficiency was consistently satisfactory at any position, regardless of the wheel's motion. How about output torque oscillations? Normally, when the wheel moves, the gears on the input shaft rotate, causing the output torque of the wheel to oscillate. Even if the linkage moves, the Uni Wheel does not produce output torque oscillations because the gear on the input shaft is not.
So this should be exactly the same with the hub motor.
Affected. This means stable and comfortable driving is possible no matter the environment. Thanks to the freedom in motor placement and ride height, safety and efficiency are greatly enhanced.
Okay, so this brings me into another thing. It looks like this system would only work for rear-wheel drive because the front wheels need to angulate sideways too to steer. And there's no way that this Uni Wheel accounts for that. It can't do that. The CV joint, you can move it in all directions. You can move it up and down, and you can angulate it side to side for the for steering. But this one, I don't see how this thing could handle steering. If anyone can figure out how this thing would handle steering, let me know in the comments below. Okay, let's see how a CV joint works. All right, so this is the guy disassembling a CV joint. This is the part that's near the transmission differential. And okay, let's skip forward. So you'll see here that this allows a lot of translational motion. It can move in and out like that. And so that accounts for the translational motion you need to keep the wheel distance from the transmission similar. Now, if you look at the other side, we're going to go to the other side. So this is the CV joint. If you look at the CV joint side, you can see you can rotate it in any direction. So it goes up and down with the suspension, but also you can angulate it side to side to allow it to steer. So it handles all of that.
Enhanced at high
But
speeds.
this thing, I don't see how you can
Plus,
angulate it
if you
side
add
to
an
side.
extra battery in the space freed up by Uni Wheel, you can improve range. When they say good things come in small packages, they mean Uni Wheel. So, is it strong enough? The first ever Uni Wheel test vehicle has passed a rigorous performance requirement test. Research is currently ongoing, and the gear ratio will be further adjusted to meet conditions for mass production. The Uni Wheel is all about maximizing the space between the wheels in order to maximize interior space.
Again, the hub motor maximizes interior space way more than this, at the cost of more unsprung weight.
This is achieved by miniaturizing the central motor and attaching it to each wheel. Independent control over drive of all four wheels results in exceptional optimal traction,
This is also an advantage of hub motors.
meeting the demands of high-performance vehicles. All-wheel torque vectoring like never before. One more important question comes to mind. Can the Uni Wheel be adapted to different mobility needs? The Uni Wheel can be adapted to different wheel sizes due to its modular design. Only minor modifications need to be made, depending on the stroke.
Okay, so the hub motors, there's also several different sizes of hub motors too, so that's an advantage that the hub motors have as well.
This modularity means that it can be adapted to any vehicle, even other modes of mobility, like delivery robots. Think of any mode of transportation. That's Uni Wheel's next target. If you're a car enthusiast, you're probably aware of how long conventional drivetrains were considered the standard. Now, Uni Wheel offers a new paradigm for mobility. Imagine the ways in which PBVs can utilize the space created by the Uni Wheel. It might just change the future of mobility yet again.
And again, this is all stuff that a hub motor would do exactly the same way.
So, that's Uni Wheel.
Okay, so I think it's a cool idea, and we'll have to see how it works. The main advantage, again, is unsprung weight advantage over hub motors. I can't figure out how they're going to handle steering on the front wheel with the Uni Wheel. That system does not handle the side-to-side angulation that steering requires, whereas the CV joint will handle that, and a hub motor will handle that. But this Uni Wheel, I don't know how it handles that. And I think they could easily add a translational mechanism to handle the translational motion as the upper and lower control arms go up and down on the steering. But we'll just have to see how it pans out. It just looks way more complicated, and it doesn't seem like it has any advantages other than the weight, but many disadvantages in terms of complexity, dealing with steering, and it doesn't offload the space as much as a hub motor is. So that's kind of my take on the Uni Wheel. Tell me what you guys think in the comments below. Thanks for watching, guys.